Hello guys, this video is part 2 of our last video where we've seen how a neural network works. Now we will go through the math, aka the boring part, straight to the point. So as we said, the network starts random, makes mistakes, checks how wrong it was, and then adjusts itself. That is how we learn as humans. We touch a hot pan, we get hurt, then decide not to touch a hot pan again. So the main concepts are: forward pass, inputs go through weights, biases, and an activation function, produces an output prediction. Loss function compares the prediction to the true value, measures how wrong the network is. We use MSC, but there are other formulas that I advise you to check. Then backpropagation calculates how each weight and bias contributed to the loss, uses gradients, slopes, to know which direction to adjust. Gradient descent and updates, optimization method that updates weights and biases, moves them in the direction that reduces the loss. Repeat forward pass. After updating, we pass the inputs again. The network now predicts slightly better. This cycle repeats until the model converges, error stops improving. That was all talk. Let's learn from an example where we need to predict the price of a house based on its size and age. The structure is 2 input nodes, 3 hidden layers, and 1 output node, which is the price. Pause the video to read the rest of the values. So let's build the network to visualize the problem. We said size and age are the input nodes, 3 hidden nodes, and the output node. Now let us assign the values starting with the weights connecting the input and hidden nodes. 0.1, 0.4, minus 0.3, 0.2, 0.1, 0.5. And the same for the hidden to output layer, 0.3, 0.7, minus 0.5. Now we do the same for the biases, 0.1, 0.2, 0.1, and 0.2. The activation function is RayLU. Assign the inputs 2 and 3 and the output 1. Let's do the calculations step by step, starting with the forward pass. For each neuron, we apply the formula Z equals W times X plus B, and then apply the RayLU. So we get 0.9, 1.3, 1. So the output is 0.88. Let us write the values in the relevant neurons. We do the same for the loss function. We get 0.0144. Next, we perform the backpropagation. After a few tiers and a few derivatives, we get these values. Pause the video if you are interested. Personally, I wouldn't pause. Now we use the previous values to calculate the new biases and weights, assuming that the learning rate is 0.0001. Direct screenshot because I am lazy to format it in the presentation. This symbol is the learning rate. Now let's remove the old weights and biases with this cool animation and replace them with the new values. Now that the weights and biases are changed, it is your turn to pause the video and calculate the new predicted output with the updated weights and biases. Then calculate the loss again and tell me what you notice. The new Y circumflex is equals 0.880014, which is closer to 1 than the previous Y circumflex. Great news. And the new loss is 0.01439996. We notice that the loss decreased slightly, which is logical because a very small learning rate leads to a tiny improvement in the first iteration. Now let's read what SpongeBob has to say on this matter. The network learns gradually. Even small updates push predictions slightly closer to the true target, demonstrating how the NN corrects itself from experience. Take a 30-second pause because I love you. Now This is the same logic using Python. We've seen these slides in the previous video for the activation function, forward pass, and loss function. And adjusting weights and biases, extremely simplified. Important remark. In real life, we have a lot of data samples, so instead of single values, we work with matrices. What you need to check is the shape of the matrices. If they align, 99% your calculation is correct. Now subscribe and like the video. Bye.